Today, we are going to start with the fundamental theorem of calculus. In here, we are going to cover the following. We are going to evaluate a definite integral using the fundamental theorem of calculus, understand and use the mean value theorem for integrals, find the average value of a function over a closed interval, understand and use the second fundamental theorem of calculus. First, we're going to talk about the connections between differentials and integrals. Now, till now, we have learned about two major branches of calculus, the differential calculus and the integral calculus. Informally, it is said that the differentials and the definite integrals are basically inverses. These are inverse operations, just like your division and multiplication. So if you recall that in a very layman form, the differentials are nothing but the slopes of the secant line. And if you take the limit of the secant lines, you get a tangent line, and that's how you get the differentials. In a similar fashion, if you find the area of a rectangle, that's delta y delta x, that's called a very approximate stage of finding the area under the curve or an integral. And if you take the limit process of the area under the curve, you actually get of the area of these rectangles, you get the area of the region under the curve. So what we see is that the fundamental theorem of calculus states that the limit process, which is used in defining the differentials and the definite integrals, it preserves this inverse relationship. So let's see what is the fundamental theorem of calculus. So what's the fundamental theorem of calculus? If a function f is continuous on a closed interval a to b, and we have capital F, an entire derivative of this f function on the interval a to b, then the definite integral of the function fx dx from a to b is equal to the capital F of b minus the capital F of a. Remember, capital F is the entire derivative of the function f on an interval a to b. So when we apply, the notation is very, very important. So certain guidelines to use the fundamental theorem of calculus. So when we normally apply fundamental theorem of calculus, what we do is we do the indefinite integral of the function a to b of the integral fx dx, and then we write that function as fx, and then we have some square brackets around it, and we say look at the limits of the integrals, and then you place the lower limit, which is at the bottom right, and the upper limit of the integral sign, which is the top right, on next to the square brackets. And then we write f of b minus f of a. For example, if I want to find 1, 2, 3 x cubed dx. Now we all know the integral of x cubed is what? x4 over 4. First we do that, and then we take, the square brackets. I normally prefer to have 2 square brackets. Makes life easier when I do calculations like this. And then I write 1 and 3. These are the lower limit and the upper limit. And then this, remember, inside part is f of x. And this will be f of 3 minus f of 1. So this one, guys, is capital F of 3 minus capital F of 1. Now what basically this means is evaluate this function at when x is 3 and when x is 1, and then you do the calculations. Now, we have learned in our indefinite integrals, we have to always put a c. But when we do definite integrals, the c doesn't make a role, because notice, if you write fx plus c, what happens? when you substitute b, f of b plus c minus f of a plus c, this constants get cancelled out. So that's why when you're doing a definite integrals, you do not write down the constant sign. Now, let's look at some examples. Okay, the first example. We're going to evaluate this definite integral 2 to 5 minus x plus 4. Now remember, this whole part is the little f of x. So the first thing we're going to do is integrate this function using our formulas we have learned earlier of integrals. So it's minus x squared plus 2 plus 4x. And then, as I said, I'm going to put square brackets outside. And the lower limit of integral is 2 and the upper limit is 5. And I write like this on the right-hand side of the square bracket. Now, remember that the inside part, guys, is capital F of x. Now then, apply the formula. This is capital F of 5 minus capital F of 2. Okay, now we're just going to substitute. This is minus f5. Now remember, minus is outside. Minus 5 squared over 2 plus 4 times 5. Now, what I normally do is when I'm doing these, when there are more than one terms, I put square brackets or curly brackets or whatever makes you comfortable. Then write f of 2. Again, I can write like that also. So it's minus 2 squared over 2 plus 4 times 2. And what you get over here is, this is minus 25 over 2 plus 20 minus, this is 2 plus, so it's minus 2 plus 8. And when you do the math, this comes out to be 7.5 minus 6, which is 1.5. Okay, now let me clean that up. So this one is 7.5. Okay, so we have done this problem. Okay, now let's go ahead and look at the next one. So here's 1 to 2 integral x squared minus 3. So the first thing you're going to do is, we remember that this inside part, guys, is your small f of x. So you will do the indefinite integral for this small part, which is basically what? It is x cubed over 3 minus 3x. Once you're done this one, write down the square brackets and write down the lower and the upper limits. And keep in mind that inside this square bracket is our entire derivative f of x. Now what you're going to do is, you're going to do f of 2, apply the fundamental theorem of calculus, f of 2 minus f of 1. So when you plug in, what you're going to see is, because there are two terms, so when you plug 2 cubed minus 3 times 2, so this is f of 2 minus f of 1 is 1 cubed over 3 is 1/3 minus 3. And when you do the math, what are we going to get? We're going to get here is 8 cubed minus 6. And 8 cubed minus 6 is minus 10/3. And then this would be 1/3 minus 3 is minus 8/3 or plus 8/3. Final answer, 2/3. Okay. Now we are going to do the next problem. Now before I do this problem, what I normally do is I try to clean this up, make my life simple. So I'm going to write this square root of x is x to the power half, and I will take the 3 outside, making my life very simple. So it's 3, 1 to 4, x to the power half dx. Now remember, if you have a constant multiplied to a function, you can take that outside and just concentrate on the function part. Okay, so remember this one, x to the power half is my function. And your 3 is outside, so make sure you keep your brackets handy here. Do not forget that. Okay, so this is 3. Now we're going to do the integral of the fx, which is basically now, and then you put the square brackets, x3 half over 3 half, 1 to 4. Okay, I'm going to need some more space. Okay, so before we go ahead, so what is this? This is going to be now 3 is outside. Now take the 3 halves up, which is going to become 2/3, x 3 halves, 1 to 4. Now remember, this 2/3 is going to be multiplied to every element. So if I can take this 2/3 outside, making my life simple. So this is going to be, if you want to do that way, or okay, let's just do this, this is fx. So it's going to be what? It's going to be now 3 times, because remember this 3 is multiplied to the whole expression, okay? So it's going to be 3 times f of 4 minus f of 1. Do you see that here? Okay, very important. So this one now is 3 times f of 4 minus 3 times f of 1. So what is f of 4? So it's 3 times 2/3 x to the power, so x is now being replaced by 4, remember. So it's going to be 4 3 halves minus 3 times, again it's going to be 2 times 3, 1 to the power 3 halves. So clearly the 3's cancel out. What are we left with? 2, 4 3 halves minus 3, 1, 3 halves. So this one, you're going to see is this is the same as a little algebra here. 4 3 halves is what? 2 squared 3 halves. And anything, 1 to the power, anything raised it is always a 1, 3. Now clearly notice this 2 and this 2 cancel out. The laws of exponent. You have 2 times 2 cubed minus 3. So what do you get here? Oh, sorry. There was the 3. The 3 was cancelled out. Yeah, I forgot that. Sorry. Yeah, there's no 3 here. Sorry, guys. Yeah. So I forgot that. So 1, 1, 1. So what you have here is 2 cubed. And that is 8. And then 2 is also outside. I forgot that. So this is 2 here. 2 and 2. Okay. So this is 2 cube. That's 16 minus 2. And you are getting the answer to be 14. Okay. Now let's look at more of these problems. Now we would like to evaluate a definite integrals, and I want to get some lower, the integrals to have some negative limits. Okay, so we're going to have minus 1 to 0, 2x minus 1. Now remember, the inside part is f of x. Okay, so when we do the integral, this is going to be what? 2x squared over 2 minus x, and it goes from minus 1 to 0. Before we apply the definite integral, the fundamental theorem, I am going to clean it up. So I have x squared minus x minus 1 to 0. Notice this is capital F of x. Now you apply the fundamental theorem, which is f of 0 minus f of minus 1. Now what's f of 0? So it's basically everything is a 0 here. So it's 0 minus, because 2 terms are there, and minus 1. So it's now minus 1 squared minus of minus 1, which is going to be what? Minus. This is 1 plus 1, 2. So the final answer, negative 2. Okay, now to do this part where we have some square roots. Now remember, whenever you have a function with only one term in the denominator and there's a variable, it's always best to, basically have the individual terms on the top with one term in the denominator, basically pull them apart, okay? So what we're going to do is we're going to first clean it up inside before I can do the integrals. So I'm going to write this as 1 to 4 x over square root x minus 2 over square root x. Okay? Then clean it up using just your simple exponential rules. This is 1 to 4, and this will be now x to the power half. Remember, x to the power 1, and then you take this on the top. 1 minus half is x to the power minus half, minus 2 x to the power minus half dx. Now we have cleaned it up, and we can now easily apply our the rules of integrals. Now remember, once again, this, guys, is your little f of x. So when you clean this up, what you get is now x 3/2 over 3/2 minus 2x half over half. Now remember, you have solved the indefinite integral, and now you're going to apply the fundamental theorem and make sure that you write down the limits. So when you clean this up, so I have to again do some cleaning. So this is 2/3 x 3/2 minus 4x half. Okay, 1 to 4. Now this one's pretty simple, won't take much time, so I'm going to use the space here. Okay. So over here, what are we going to see? Notice this part, guys, this part here. This is your capital F of x. So now you're going to do is f of 4 minus f of 1. Now that means you're going to have 2/3 for 3/2 minus 4 for 1/2. So that is f of 4 minus f of 1, which is what? 2/3, 1 3/2 minus 4, 1 to the power half. And when you do the math, what you're going to get is this one is going to give you, this whole thing is going to give you negative 8/3 plus 10/3. Final answer, 2/3. Okay, it's all algebra, guys, over here. Now let's look at 0 to pi 4 secant square x. If you guys remember, the integral of secant square is tangent x. So this is very simple. It is tangent x 0 to pi 4. Now your antiderivative, guys, over here, remember this one is capital F of x, which is now f of pi 4 minus f of 0, which is tangent pi 4 minus tangent 0. Now notice tangent pi 4 is what? 1 minus 0. Final answer, 1. Okay, so we are getting the hang of this little, idea of how to use definite integrals. So what I'm going to do, guys, is I am going to let you practice what I have done some of these problems. So before you venture and look at, other more difficult problems in definite integrals, I have written down a bunch of these problems for you to practice. They're very similar in kind to what I have just done earlier. Okay, so please practice these 2 slides. Very important when you practice them. And next time I will continue with a little bit more difficult integrals. Thank you.